So this is the third session of implementing a Lisp with Python. Last time we implemented a basic parser for atomic values. And this time we are going to finish the recursive descent parser and add more debugging functions to the Lisp runtime. So first of all, there is something that I forgot last time. So the Lisp built-ins must be functions that manipulate Lisp values. So this function, which returns a string, is not correct because it returns a Python string instead of a Lisp string. So this is the correct version of this function, but now from the parse file, if I try to print it, it's not going to work because it's weird. So oh yeah, it's working, but it's not printing the values because it's creating a new Lisp value. So I need to extract the Python string in the Lisp value, and now this works. So now we are going to implement toString for the string type. And for the symbol type. And it works. So for the recursion, I'm going to add a new value to parse, which is a recursive value, which a value which contains other values. So in this case, we need to parse new tokens until we find the end of the list. So I'm going to create a sub-expression list and use a while loop to read new tokens, or new tokens, until I can reach a closing parenthesis. and the expression parser needs to return a Lisp value. So after finishing the expression, we need to create a value with not a list type, but either a nil type, a unique type if the return value is nil, or a cell type if the return value is a non-empty list. And before that, I also have to use a Lisp list instead of a Python list. And to do that, I must import or create the values. That I'm going to use later. And I'm also going to use these functions to manipulate lists. So instead of appending, I'm going to use the cons function to add a new element at the beginning of the list. And because a list is always a Lisp value, it's always a value, I can just return it without creating a value wrapper over the list. So the parsing has finished. The parsing has finished, but the value cannot be printed because there is no print or string conversion for Lisp lists. So I'm going to write one. So in Lisp, Lisp values are represented this way, where there are parentheses around the list and elements are separated by spaces. Just to remind you, unique values are implemented as a value wrapper over a label, and the unique values cannot be compared with object identity because there is no guarantee that I'm not going to do something like this in some other place, and then if I try to compare like this, the result should be true, or not. No, it shouldn't. Let's say it's not defined. The unique value should not be created more than once. So I could use object equality in this case to compare values, because the default Python equality for objects is object identity, which means that in memory this is the same value. Two objects have to be the same value in order to be equal, which is correct. And this one is wrong, because if I want to make another unique value with the same name, the values should still be different. So I'm going to remove this. And I'm going to compare with simple object equality. I think the AI completion has crashed. So here I'm going to take the first element of the list, convert it to a string, take the Python string and concatenate to the result. And if there is, if the list is still not empty, I'm going to add a space to prepare for the next values, the next value. This didn't work. I got an infinite loop because I didn't do this to remove the element, and it doesn't work, but I think I know why. Because in this code, so you see here there are two problems. First, the hello world string is not printed with quotes. It's not represented as a Lisp value. It's represented as a printed string, which is printed the way with its characters and not with and not as a literal value. And the second problem is that the print call is reversed. It's printed after the hello world. So to fix this, the problem is probably from here, because the tokens are reversed. No, this is not the problem. Yeah, so because the tokens are reversed, print is parsed first before hello world, and then hello world is added with cons, which is not what happens in the correct Lisp. So in Python, for example, if I have this list literal, the A comes before the C, and the A is parsed first, and then C is appended. But in Lisp, the function to concatenate to add a new element to a list, which is cons, adds at the beginning of the list. So this means the list is always going to be built in reverse, so I have to reverse it first. And this cannot work because it's not a Python list. So to reverse a Python list, there is an algorithm that's easy to apply. The idea is that if I just have to take the first element and add it to a new list. So I'm going to create a new list which is empty, and then I'm going to add A and remove A here, then add B, then remove B, then add C, remove C, and then add D and remove D. And this algorithm is used because in Lisp, lists can only be modified at the beginning in a constant time complexity. So if I wanted to remove the last element, I would have to go through the entire list. It's kind of like when I do this in Python, I would have to move each element of a table to be able to remove the first element. In Lisp, it's the opposite. I have to remove the first element first, and then the second one, and then the third one, and then the last one. So I'm going to create a new list, and while the list is not empty, I'm going to take the first element and add it to the result. And this should work. Oh, no, I forgot to import it. So now there is another problem. I don't know why the problem was not here before, but the last element of a list is always nil. So if I I don't know why there is a problem here. So apparently the string conversion is trying to cast nil, which is the last element of a list, but this value should not be converted because it's not well, it's a delimiter. It's not an element of the list itself. So I'm trying to use the function, the toString function I implemented to debug the state of the program. I think I'm going to move this algorithm as a primitive operation of this of the cell data type. It's not going to fix anything, but it should make the code simpler. So apparently something changed, and the problem is still here, but I'm not sure why. Oh yeah, I forgot to return it. Yeah, and now this works. So I'm not sure what I did. What did I do that created a bug? But apparently I fixed it. And now the second problem is that there are two ways to represent values in not just Lisp but also Python. So in Python, if I try to type a value, the Python interpreter is going to represent it as a Python literal, meaning that I could copy paste it and it would still be a valid Python value. And then when I print something, it's not going to print it as a Python value, it's going to print it as a user displayable message. So if I try to print integers, it's not going to change anything because the integer as it is printed is a valid Python literal. But for strings there is a difference, and for other values I think there is also a difference. No. So I'm not sure if there is an example of other than strings, but in Python the difference between these types of representations comes from str to convert to string and to represent. So if I use str to convert to a string, I'm going to get a string, and print will print it that way. But if I use rep of a value, it's going to add a wrapper around the string to be able to copy paste it as Python code. So if I try to print rep of x, I'm going to get the same thing as if I typed x. which is what the Python interpreter does. It's going to call the rep function to represent a value as a Python code that can be used as Python before printing it. And that's what I want to do here. So instead of printing, instead of converting to a string and just concatenating hello world, I'm going to represent it as a Python, as a Lisp literal, which is going to be this, before printing it. So I'm going to add a new built-in, which will be called represent, but I'm going to call it rep in Lisp. This function will be called toString in Lisp, and the represent function is going to do the same job as toString, except it's going to represent it as a valid Lisp code. I'm going to start with the string, and that's it. So if I use, if instead of using toString I use represent in the Lisp formatting, which by the way is the same as Python, because in Python if I try to print an array, it's still going to represent the values as represented Python literals, and this is not going to do the same thing as if I tried to print a string directly. Here there is no quote, and here the fact that the b is inside a list will tell Python that b has to be represented as a Python literal. And the part of the behavior, this behavior is implemented by this method, which is called by calling the string cast. So if I try to convert an array to a string, the elements are going to be represented as Python literals and not printed as simple strings. So this is what I'm going to do here. Instead of calling toString, I'm going to call represent. And I'm going to add the same mechanism here, the same exception. So now the exception is telling me that the represent function is not implemented for the symbol type, which is normal because the print symbol is represented as it has to be represented as a Lisp literal and not printed like it was before. So I'm going to implement this here. And for symbols, because they are variable names, a symbol just has to be written that way. So for example, if I want the symbol for the value print, I'm just going to write print to be able to evaluate it as a valid code. So now it works. And I can print numbers, strings, symbols, and also complex expressions with sub-elements inside. I'm going to replace the call to toString in here by call to to represent because I want to make a distinction between this string and this symbol. So now I need to implement the represent behaviors for all the types I did here. But because the behavior is the same, I can just do this and I'm going to reuse toString instead of re-implement it, instead of copy pasting the code. Because this way I can reuse the same representation for both represent and toString. So now I can represent any Lisp value with just the represent function, and it's going to represent it as a valid Lisp value. So I could copy paste this in my Lisp code and evaluate it. And these functions are going to be part of the bootstrapped built-ins in the Lisp runtime. So these functions are going to need to I'm going to need these functions to be able to support the most common cases, so most Lisp types, which are defined here. Because once I can run new Lisp definitions and override the symbols with new Lisp functions, I will be able to implement things like polymorphism and support dynamic type dispatching instead of having hard-coded functions with a list of a switch over the type. So now we have the complete parser with the recursion, and we have a complete representation of any value, but we lost the source mapped equivalence. So I would like the print function, or maybe a new function called debug, to print a value and also print the metadata if it exists. So in the value type definition, I have defined start position, start line, end position, and end line attributes, and I'm going to use them and I'm going to reuse what I had here in the tokens. To represent a value as not only the value itself, but also where the value was defined and read in the file, in the source code. I'm going to rename the debug function to inspect, because debug is too general. I could have something else called debug. And I'm going to inspect the values. I don't know if I'm going to, yeah, I'm going to put this as a Lisp function, so I'm going to have to return a Lisp value, and this is already correct. And now you can see that this integer is defined at the third line. This value is on the fifth line, this one on the seventh, and then the last value is not correctly debugged because in the parser this function is not going to create a new value from cons cell operations with cons and nil and reverse, but it's not going to use the tokens directly in the with their metadata. So I'm going to use the parentheses which are here and here in order to add metadata on where the value is in the source file. So here I'm using the position of the first opening parenthesis to report the error as so I'm reporting the error with additional metadata on where the error happened, where the list that was not finished started, to help debugging to help the user to debug their source code. And I can test it with this. So here this function is incomplete, this expression is incomplete, and because it's incomplete, the compiler will tell that on the 13th line there is an expression that is not finished. So before returning the result, I'm going to add metadata, and here I have the correct error, but it's not working as expected. So here I can see that on the first character of the 13th line I start a new expression which is never finished. So if I have a text editor like Vim, I can switch back and forth from the first and last parenthesis, and the parenthesis is changing color when I have my cursor on it, and the matching parenthesis also changes color. But here, if I go to this parenthesis, I don't have the same highlighting, it's not the same color, and I can't switch from the first to the last parenthesis. So I can confirm with my editor what the output of the interpreter tells me. So I'm going to remove this to be able to finish, and now I can get the correct positions, which I can see here in at the bottom of my screen. So I think this is enough for this video. We finished the recursive descent parser, we implemented more debugging functions, and we added source mapping to the values that are read in the source code. I'm going to commit everything, and I'm also going to add something that I didn't do before. I'm going to add a git ignore file to remove the pcache, the Python cache files. So now this cache files are not going to be added to Git when I want to commit everything. And that's it.